Alright, welcome back. Now we're going to turn off the voltage source, turn on the current source, and see if we can figure out what Vx is just due to that current source. Again, not sure why they labeled these two the same. So that might be a typo on the sample test that I found. So let's read, which is required as part of the exam. Remember that when we turn off a voltage source, an active voltage source, it becomes a short. So we've got the following circuit, and we're going to detax this because there's no current running to the output. And there's our equivalent circuit with V1 turned off. And again, our goal is to find, we don't need to find the voltage at every node. We're only looking for the contribution of this current source to create this voltage right here. So let's try again. Let's do some current analysis. So we'll have a loop. We'll use our IA, IB, and we'll use an IC here. Let's see what we got. So let's start right here, this node. So we've got a drop. So 0 equals the drop in the direction of the current, which is minus Vx. And then the drop in this direction, it's IA minus the current opposing it, which is IB, times the resistor 1K, plus the drop in this direction, which is IA minus the current opposing it, which is IC, times 4K. We're back here, so we're done. So that's our first equation. Next equation, let's start here. Well, let's start here. We had this problem before, so we called that V2 before. Let's do it again. So we start here and we go in this direction, and we've got a drop of IB minus the current opposing it, which is IA, times the resistor 1K, plus the drop across in the direction of IB, which is just IB, times 2K. And then here the voltage drop in the direction of the current. The voltage drop is 0 minus V2, or negative V2. So that's the second loop equation. Now the third loop, let's start here at 0. So we go up this way. There's going to be a voltage here which we don't know. I'm going to call this V. I might need to know this voltage. Let's call this VC. I don't know why, and we'll call that V3. So we'll start at V3. Drop across this resistor, which is the direction in IC, minus the current opposing it, IA, times the resistor 4K, plus the drop in this direction, which is just V2 minus 0, plus the drop from here to here, which is 0 minus VC, plus the drop in this direction, which is going to be IC times the resistor, 2K. So we didn't need to know what that one is. Not necessary. Very good. Okay, so let's see how many unknowns we've got. We've introduced IA, IB, and IC, so that's at least 3 unknowns. We've got Vx, a 4th unknown. We introduce again V2, a 5th unknown. But it looks like, again, we can, so 3 equations, 5 unknowns. We need 2 more equations. Let's see what we have. Well, it looks like right here in this loop, IC must equal I2. So that'll make it a known. So we can, as we simplify these equations, we'll plug in where necessary. So we have 0 equals negative VXIA. Now, why did I do that? That's actually incorrect. This should be just IA times the resistor. Hope somebody caught that. So IA times the resistor, because it's the current flowing in this direction, and then you just have to multiply by the resistance. So that should be 1K. Which means we don't have Vx in this equation, so we will have to come back to that. So IA1K plus IA1K minus IB1K plus IA4K minus IC4K. But again, IC is just I2. We've got 0 equals, we can combine the IAs to 6, IA6K minus IB1K, and then this IC becomes I2, which is known, or I2 we'll just plug in 2 times 10 to the minus 3 times 4K, which is 10 times 10 to the 3. So we know these are going to cancel. This will become 8, and we can move that to the other side. So we've got 8 is equal to IA6K minus IB1K. And we can hold there for now for that equation. And all of that I didn't show you. Goodness gracious. So again, I started with this equation, came here, realized I had made an error here. It should be IA times just the resistor, not IA times the voltage drop. It's IA times the resistor. I could have just done voltage drop, and we'll see later that I can replace this whole thing with a negative Vx. So, and I distributed and simplified, so I distributed across here to get each of these. I combined like terms for the IAs. It came out to IA times 6K, negative IB 1K, and then I see I replaced with I2, which is 2 times 10 to the 3. 4K I replaced with 4 times 10 to the 3. So the 10 to the negative 3 cancels 10 to the 3. This becomes 8. Move it over the other side, and I'll stop there. Now I'll pick up my next equation. Now you can see how in a test you're going to have to move a lot quicker. I'm going through more slowly and methodically, although I wish I could be more organized, just to show you everything that's going on. Hopefully that'll help you understand better and thus answer these questions more quickly. So I'm going to simplify the equation. So we've got negative IA 1K plus IB 1K plus IB 2K minus V2. I'll bring the V2 to the other side, and we're left with minus IA 1K. I can combine here, so plus IB 3K. We can hold right there. And then lastly, we've got this equation. Oh, not that equation. I mean this equation right here. Alright, so we're simplifying this last equation here, which was our third loop equation. We've got 0 equals negative IA 4K minus IC 4K plus V2 minus VC plus IC 2K. Well, we have a few opportunities here for simplification, thank goodness. Recall from our circuit diagram that IC must equal I2 because they're in the same direction. That's the only other current that flows through that wire. So here we go. We've got 0 equals negative IA 4K minus, oh well, let's see, let's simplify these two right here. So we got a minus IC 4K plus IC 2K. That becomes a minus IC 2K, and we can replace that IC with I2, which is 2 times 10 to the minus 3. The 2K will replace with 2 times 10 to the 3. And then we've got plus V2 minus VC. Let's see. So this is the powers of 10 cancel. This becomes minus 4. I'm going to bring it over the other side, so I've got 4 is equal to let's see, minus IA 4K plus V2 minus VC. Okay, so we'll hold there. Let's bring back the other equations that we identified, namely these two. 8 equals IA 6K minus IB 1K, and then V2 equals minus IA 4K plus IB 3K. Alright, so remember, all we're really looking for is Vx. That's all we really care about. We don't even have Vx in any of these equations, so we need to go find that. So right here, we've got this drop, IA times 1K, must equal negative Vx. It's going from this minus this point. So that will give us a negative Vx. So negative Vx is equal to IA times 4K. Alright, so let's work from here. So that is equal to, probably the best way we can either, well, here we've got these two nasty unknowns. Putting it in there isn't going to help us. So I think we can, probably right here is got the least number of unknowns. So Vx over 4K negative is equal to IA. So I can plug that right in here. So 8 is equal to negative Vx over 4K times 6K minus IB 1K. Now we go back to our circuit diagram and see if we can replace IB with things that we know. Well, look at this. Right here through this wire, we can see that this current must equal IC minus IB. But we said that IC is equal to I2. So this current right here has to equal this current, I2 minus IB. So let me write that over here. So again, just keeping the circuit diagram in mind, what we're saying is that our known current 4E minus 3 Vx must equal IC minus the current opposing at IB. But IC, we've agreed, must equal I2. And I2 is equal to 2E minus 3. Good. So now let's simplify further. Let's see. So we can, what we want to do is, if we can solve for IB here, we can plug it into here and solve for Vx. So let's bring IB over to this side, this Vx factor over to that side. So we have IB is equal to 2 times 10 to the minus 3 minus 4 times 10 to the minus 3 times Vx. And we can use this to plug it right into this one. So here we go. 8 equals negative Vx. The 4k over 6k simplified to 3 over 2. Minus IB. Minus IB is minus 2, minus IB. 2 times 10 to the minus 3 minus 4 times 10 to the minus 3 Vx. Looks like we can factor out a Vx. And we're left with minus 3 halves. Oh, I should have distributed this. So, let's see. Let's do that. It's a lot of work to make a mistake like this. So, 8 is equal to minus Vx 3 over 2 minus 2 times 10 to the minus 3 plus 4 times 10 to the minus 3 Vx. Factor out a Vx. And we've got negative 3 halves minus 2 times 10 to the minus 3 plus 4 times 10 to the minus 3. Oh, whoa, wait a second. This doesn't have a Vx. We can't do that factoring. I feel like my Algebra 1 students. So let's get some more paper and continue on. So let's go. So we can bring this over. This is going to have a negative sign, so it'll be 8 plus 2 times 10 to the minus 3 is equal, and then factor out the Vx. Minus 3 halves. This negative distributes, that's a positive. So plus 4 times 10 to the minus 3. Divide, and we're left with 8.002 divided by, so this is 0.5. You know what, let's just leave it like that. Minus 1.5 plus 4 plus 0.004. And let's plug it into our trusty calculator. Again, use a nice calculator, don't use a TI-83. And I'm plugging that in right now. And we've got negative 5.349 approximately. And that's just due to the contribution of the current source, with the voltage source turned off. So I'll stop here and then we'll add things back together.